Hello everyone, in today's video we are going to cover section 2.1, Perpendicularity. After studying this section, you'll be able to recognize the need for clarity and concision in proofs and understand the concept of perpendicularity. Perpendicular lines raised in segments. Perpendicularity, right angles, and 90-degree measurements all go together. So the definition of perpendicular is lines, raised, or segments that intersect at right angles are perpendicular. So if we were to put this in a conditional form, we would say if two lines are perpendicular, then they form right angles. Below we have some examples of perpendicularity. So I have A is perpendicular to B. If A is perpendicular to B, that would tell me that all four of these angles are right angles, and they all are 90 degrees. Now in my middle diagram, I have line segment DE is perpendicular to line segment EF. If these are perpendicular, again, angle DEF would be a right angle. So it would also be 90 degrees. And then my last, I have line segment JM is perpendicular to ray GH, making, again, all four of these angles right angles. Because if one angle of a straight angle is a right angle, then the other angle of a straight angle has to be a right angle as well. Because we know straight angles are supplementary, meaning they add up to 180. 180 minus 90 is 90. Now in my figure at the right, the mark inside the angle, this little mark here, indicates that angle B is a right angle. So it's also true that line segment AB would be perpendicular to line segment BC, and angle B is 90 degrees. Now what we don't want to do is assume perpendicularity from a diagram. Just because it looks like angle DEF is a right angle, if I don't have this box here, I cannot say it is perpendicular or it is a right angle. So do not assume 90-degree angles. Now looking at some proofs, I have given line segment AB is perpendicular to line segment BC, and line segment DC is perpendicular to line segment BC. I want to conclude that angle B is congruent to angle C. Now, again, as I go through these proofs, I find it the easiest to mark my diagrams with my givens and then derive information from that. So I know that line segment AB is perpendicular to line segment BC, so that would tell me that angle B is a right angle. And I also know that angle D is a right angle because line segment DC is perpendicular to line segment BC. So angle C would be a right angle. Now I know that both B and C are right angles, therefore they are congruent. Now when I write my statements, there's two options that I can do. I can list both of my givens and then derive information from that. But the way that I like to do them is I like to list one given, then derive as much information from that given as I can. Then once I can't derive any more information, then I list my second given, derive more information, and then tie everything together at the end. So my first statement here would be my first given, which is line segment AB perpendicular to line segment BC. Again, that's given. Because of this, I know that angle B is a right angle because of my conditional statement of the definition of perpendicularity. If two line segments are perpendicular, then they form a right angle. Now I can't derive any more information from this, so I'm going to go to my next given, which was line segment DC perpendicular to line segment BC. Again, now from that, I know that angle C is a right angle because that's the same reason as number 2. So I can say same as 2, or I can write out if two segments are perpendicular, then they form a right angle. Now that I have B as a right angle and C as a right angle, I remember my first theorem, which was our right angle theorem. If two angles are right angles, then they are congruent. So I can say angle B is congruent to angle C because if angles are right angles, then they are congruent. Looking at problem 2, we're given line segment EH is perpendicular to line segment HG. Name all the angles you can prove to be right angles. So if these two line segments are perpendicular, then I know angle EHG would be a right angle. Now from my diagram as well, it looks like angle EFH and angle GFH would be right angles. However, I don't have my box that indicates they're right angles, and I don't have any perpendicularity statements for line segment EG and line segment HF. So the only angle that I can show that is a right angle would be angle EHG. Problem 3, I'm given that ray KJ is perpendicular to ray KM. Angle JKO is 4 times as large as angle MKO. Find the measure of angle JKO. So they give us in this diagram that JKO is 4x and OKM is 1x. They also tell us that it is 4 times as large. So if they weren't giving us this 4x and x, you can list one angle as a variable, and then based off of the information that you're given, you can modify the other angle from that variable, which is what they did with the 4x and the 1x. So if these are perpendicular, I know that they make 90 degrees. So 4x plus x would equal 90. 4x and x is 5x. So 5x equals 90. I'll divide everything by 5. So x will be equal to 18. I'm looking for the measure of angle JKO. I know the measure of JKO would be 4x. So 4 times 18 is 72 degrees. So the measure of angle JKO is 72 degrees. Problem 4, I'm given A is perpendicular to B and C is not perpendicular to D. Can I conclude that angle 1 is congruent to angle 2? Well, I know if A is perpendicular to B, that angle 1 would be a right angle. If C is not perpendicular to D, then I know that angle 2 is not 90 degrees. Therefore, angle 1 is not congruent to angle 2. In problem 5, we're given line segment EC is parallel to the x-axis. That's what these two little up and down lines mean. That means parallel. And then line segment RT is parallel to the x-axis. We want to find the area of the rectangle RECT. So I'm given coordinates R of -4 and -2, and then coordinates of C of 7 and 3. So I need to find coordinates of E and T. Well, if I find the coordinates of T, I know T will have the same x value as C, so it'll be 7, and it'll have the same y value as R, so it'll have -2 as its y value. So the coordinates of T are 7, -2, and then E would have the same x coordinates as R, so -4, and then it would have the same y coordinates as C, which would be 3. Now using this to find my length and width of my rectangle, I know my length would be from -4 to 7, so that would be 11 units long. And then my width would be from -2 to 3, so that's 5 units long. I know area of a rectangle is length times width, so 5 times 11 would give me an area of 55 units. In this lesson, we learned if two lines, rays, or segments are perpendicular, then they form right angles. That's a wrap on this video. We'll see you in the next one.